All right, well, we are going to start on page 110. There's a few word problems on here that really might take you back to your junior high days. In fact, in 8th grade pre-algebra, these are the kind of word problems we've been working on for the last little bit. And they're word problems that, frankly, if this is on a standardized test, ACT, SAT, achievement test, you probably figure it out and do it all in your head. But because it's algebra class, you have to write a proportion. But word problems, we would set up proportions. So we're going to take a look at that first word problem there on page 110. Word problem 29. And Genesis, if you'll go ahead and read that word problem for us, please.
The school janitor can clean 4 rooms in 24 minutes. If the janitor has 60 minutes left to work, how many more rooms can he clean?
All right, so in setting up a proportion word problem, taking you back to your junior high days, you take the comparison or the ratio that's given. And the ratio here is the 4 rooms to 24 minutes. And so what we taught you in junior high in a problem like this is you start with the ratio and you identify what to what. This is rooms to minutes. Make sense? And if that's the ratio on one side of the equal sign, you'd make a ratio on the other side that is also rooms over minutes. The other number that they give us, class, is the number 60. And that 60 is 60 minutes. So would I put that in the antecedent or in the consequent? In the consequent, because it was 60 minutes. And when it asks how many rooms does he have left, well, of course, that's the antecedent. And to solve a proportion, class, we could cross multiply. It's not terribly hard. Cross multiply, we have the means. And the product of the means equals the product of the extremes, which is 240. And is there an easier way to figure it? Probably, but not too bad this way either. X is equal to 10 rooms. He can do 10 rooms in the 60 minutes he has left. How many remember doing this in junior high? Rooms over minutes equals rooms over minutes. Okay, so looking at number 30. Go ahead and read that one for us if you would, Brandon.
2 tanks are being filled to accommodate trucks traveling down a highway. If 54 gallons of fuel will fill 4 tanks, how many gallons will be needed to fill 9 tanks?
All right, so what's the ratio we should write first, Brandon?
4 over 54.
Okay, I was going to do 54 over 4 because that was the order it was in, but we can do 4 over 54, where the 4 is the number of tanks that are filled by 54 gallons. These seem like really small tanks. All right. Well, these are, yeah, even so, I mean, that's for a truck tank? Anyway, whatever. And the other number they give us is 9, and that's the number of tanks. So I should put that in the numerator, antecedent, or top if we want to be really boring about it. Okay, 9 tanks. And the question is how many gallons. So that's the x in the consequent, or in the denominator in the bottom. And here it becomes a little bit more needful to cross multiply. Calculators certainly would help here. Of course, 4 times x, class. 4x. 9 times 54.
486.
And then, of course, to solve, we simply divide away the 4. Or if you put it in as a fraction, 486 fraction 4, it'll give you your mixed number answer all reduced down and everything, class. 121.5 gallons needed for 9 tanks. Okay, feel like you got it? I set up the proportion to solve number 31. How many wish you could go back to junior high math? Your good old days. Of course, you couldn't use a calculator in junior high math, right, Abby? Yeah, sad day, sad day. So maybe we don't want to go back. I don't know. And what's your proportion, Michael?
2 over 5 equals x over 15.
There we go. When we've got blue is to white as blue is to white, you can do this in your head. What do we get? 6. How many is 6 gallons of blue paint needed? All right, any questions on that? I don't even know if you'll be tested or quizzed on that. I don't seem to remember that ever being on a test or quiz. Maybe it is. But if nothing else, it's a nice little review of mathiness to get us back into the flow of things. Let's review what we've been talking about lately, and it was Equations in the quadratic form. We've been talking about quadratics for, it seems like, forever. We had completing the square. We had the formula, which is hiding back there on the cabinet. We had, setting it equal to 0, the factoring method. And we said that quadratic equations are squared, first, gone in their complete form, right? They don't necessarily have to have the gone. In fact, they don't even have to have the first power. They would be incomplete or pure. But we said as long as you had a doubled exponent, single exponent of what was doubled and then gone, that would be quadratic form. Like, for instance, write this down, 3x to the 4th negative 25x squared equals 18. It's not a quadratic, but it's in quadratic form, so we solve it like we would a quadratic. What would we need to do here? Audrey?
You move the 18 over as a negative.
Good.
And then backwards forward.
Good. Move the 18 over as a negative 18, so it's set equal to 0, and then factor it. Backwards FOIL, as she said. Okay?
3x squared and x squared. Plus and minus. 2 and 9.
All right, check your outer inner. All right. And then what would we need to do? Let's go to Abby.
Set them both equal to 0.
All right, and in so doing, we get a couple of little incomplete quadratics.
X squared, x squared minus 2 over, no, x squared equals 2 over 3.
Well, when we move the 2 over, it becomes a,
Negative 2.
good, you started to say negative 2 over 3, there we go. And of course over here, we move the 9 over 1 over the next squared equals 9, right? And of course, here move the 2 over as a negative and divided by 3, did both steps. And then, once we've got the x squared isolated, Maddie, we have to. And right here, that's not a problem at all, class. The square root of x squared is just x, and the square roots of 9, Kendall. Positive negative 3, but then right here, we're trying to, well, of course, square root of x squared, again, still x, but we're trying to take the square root of a negative. Class, anytime we're supposed to take the square root of a negative, what's our key step? Hey, that's pretty good. We just had Thanksgiving break. Those watching on YouTube might not have, depending on the timing they're on. But yeah, we just got back. Pull out your I. We remember that. So we end up with I square root of 2/3, or really because we took the square root class, positive negative I squared root of 2/3, but I can't even leave that answer. Why not, anyone? Yeah, you can't have a fraction, you can't have a denominator inside the radical. So I'll have to multiply top and bottom here, Genesis, by 3. So that instead of 2/3, it becomes positive negative I times the square root of 6/9. The whole point being, I can now take the square root of to get
3.
So our final answers here, both imaginary, will be
Positive negative square root of 6 over 3.
there we go. Maybe you said the I, just didn't hear it, but positive negative I squared root of 6 all over 3. 2 imaginary answers, 2 real answers for a total of 4. Remember, we said we're always going to get as many roots or answers, not always real, as the leading coefficient. At your seats. I want you to work this problem. Take just a moment or two on that one. Audrey, what did you do first?
I moved the 9x squared and the 36x over.
To get?
X squared, x cubed plus 9x squared minus 36x equals 0.
And this isn't technically in quadratic form because it's not doubled, regular, gone, But what can I do next before I can worry about quadraticness or not, Michael?
Pull out an x.
I can pull out a common factor of x, leaving us with,
X squared plus 9x minus 36.
and so this portion is at least quadratic. Then, Brandon, I assume you did this, and then backwards FOIL this part of it to get
X and x. Positive.
And this is where we got stuck. Somebody help? 12 and 3, right? We want a 9. 12 times 3 gives 36, but 12 and negative 3 gives positive 9. There's one little thing we've forgotten here. Yeah, bring down the x. He didn't forget. I forgot to write it. Continue.
Say everything goes in.
And we're going to end up with 3 different answers for x. What are all 3 x answers you got? Audrey, I believe you were the first one done.
0, negative 12, and 3.
There we go. Anyone else get those same 3 answers? All right. Some of you were not able to finish. How many were on the right track at least? All right, any questions on this problem? We'd also been looking, if you turn to page 133 now, at equations that involve rational exponents. And that's where we left off in our last lesson. Again, for those in the classroom, it was about a week and a half ago. So it's been a little while. Take a look at number 19 there on page 133. If you would go and copy it down onto your paper. We've got a w to the 1/3 minus 4w to the 1/6 plus 4 is equal to 0. And one of the things I suggested with these fractional exponents is it really helps if the denominators match. So instead of leaving 1/3, class, what might we do with that 1/3 they gave us? Anyone?
2/6.
Make it 2/6. That'll match the denominator of 6 that we see over here. So kind of make that little edit to what's given to you. It'll help you see that we do have a doubled exponent here. And then, of course, doubled regular gone. So this is in the quadratic form. It's already set equal to 0. So, class, we can factor. And here comes the question. How do you suppose we should split? Again, it's been a week and a half for us. For some of you, it was yesterday. But how do we split a w to the 2/6, Abby?
W of 1/6 and w to the 1/6.
W to the 1/6, W to the 1/6, right? Put 1/6 of a W on both sides. That gives a total of 2/6 of a W. Signs, of course, class?
Negative.
Both negatives. And how should we split the 4?
2 and 2.
It's got to be 2 and 2. By the way, you realize then this is a perfect square trinomial in a way. It just happens to have a fractional exponent, so it's also not quite a PST, but kind of is like a PST. So in both cases, when we set these equal to 0 and move the negative 2's over, class, we're going to get w to the 1/6 equals
2.
positive 2. Happens that they both come out to that positive 2. Now what? This so far has matched everything else we've done, but this is where it gets a little different. Because we need to realize what a 1/6 power actually means. Raise of hands, who remembers what a 1/6 power means? Brandon?
The 6th root.
The 6th root. This could be written the 6th root of w equals 2. Do we see that it's really the same thing? So here, we've isolated the radical. My 2 key steps to solving radical equations: isolate the radical, square both sides. But in this case, we wouldn't square both sides, class. We would 6th power both sides. I don't know if there's a better way to say that. You know, we raise both sides to the 6th. Well, we don't have to write it as a radical to see that. Because if you raise to the reciprocal power, 6 over 1, when you raise a power to a power, class, you multiply the exponents. And if you multiply by a reciprocal, it always cancels to give you a 1. So we could have seen that here to get w, and then raise 2 to the 6th, class, to get 64. And that's going to be one answer. Over here, you would get the same answer a second time. They would be coincident roots. How many roots should we have? Well, it's hard to say. It's a radical equation. So there's really no telling. It's not like here where it's an integer. 3 roots, 4 roots, a third of a root. That kind of breaks down with a radical equation here, but we'll at least get W equals 64. However, because it is a radical equation, though in disguise, it's possible, class, this answer could be extraneous. So we always need to check. I'm going to go back to what was originally written right here, the 1/3 power. Because the 1/3 power, class, simply means cube root. What is the cube root of 64? 4. What is the 6th root of 64? 2. Times -4 plus 4 is equal to 0, yes or no? Yep. Okay, so this time it checks, and of course the other 64 would check if we even wanted to bother. But there would be our answers, I guess. 64 and 64, there's our answer, 64. Questions? How many vaguely remember doing fractional exponents before we left? All right, only a couple of you. The rest of you are like, I'm still thinking about turkey or football. That's me, football. It was a great weekend for football. Anyway, we don't have time for football, unfortunately, not right now. Let's take a look at number 11, where we've got an r, it says to the 1/2, plus 8r to the 1/4, positive 15 is equal to 0. All right, thoughts here. Audrey.
Make the 1/2 2/4.
There we go. You did a great job with that last time, so I'm going to go back to it there. Let's make this a 2/4. So I just think it helps make everything easier. Okay, now Kendall, what do we do?
Back this way.
Mm-hmm.
R to the 1/4. R to the 1/4. Positive and positive. And 5.
And checking the outer inner. Yep. All right, Michael.
Then you gotta send both equal to 0.
So yeah.
R to the 1/4 equals -3 and -5.
All right, and then what do we need to do here, Maddie? Good. If you'll raise to the 4th power, that 4th power will knock out the 1/4 power to give us just r in each case. But we also need to raise the -3 to the 4th. Again, the y to the x button on your calculator can do this, or the caret button on your calculator. Or maybe you're just that good. -3 to the 4th
81.
is a positive 81. What about -5 to the 4th? 625. All right, but we need to check these answers, don't we? Because anytime you are raising to a power, like in a radical equation, which in a way this is, we could create extraneous roots. Again, I'm going to go back to thinking 1/2 power here, or square root. What's the square root of 81? 9. The 4th root of 81
3.
times 8
24.
plus 15 is equal to 0?
No.
Oh. Okay, how about 625? What, the square root of 625 is 25. What about the 4th root of 625? That's one we memorized. 5 times 8? 4. Plus 15 is equal to 0? Ooh. Thoughts?
No solution.
No solution. We got 2 answers, neither of them check. There is no solution to this. 2 extraneous roots out of 2. Questions on this one? Let me give you another one. At your seats, you work this one here. X to the 4/3 equals 17. X to the 2/3 minus 16. Remember, if you raise to the reciprocal power, that's going to be key. And your calculator can handle fractional exponents. But I'll show you how to think it through without the calculator if you're interested. Well, even if you're not interested, I'll show you. I guess you can, if you want to start on this one ahead of time, you can. Some of you already finished. We're just going to look at that last one here. How many of you at least got to this point? X to the 2/3 equals 1, and x to the 2/3 equals 16. You at least made it that far. All right, any questions on how I got that far? I've shown the work. Does anyone need me to kind of explain what I did there? Going once, questions? All right, once I've gotten to this point, what power do I need to raise everything to, class? The 3/2 power. So that when you raise the power to a power, multiplying the exponent, the 3's cancel, the 2's cancel, I'm left with just plain old x. And then here, well, 1 to any power, class, is 1. So, I mean, you can't possibly mess that up, right? Here, 3's cancel, 2's cancel, I'm left with x. Here, x to the 3/2, you can plug it into your calculator, or you can say this: what's the square root of 16? 4. Technically, my idea to take the square root, for that matter, same thing here, right? 2 to any power, or the square root of 1 is technically both positive and negative 1, right? When you cube a positive 1, but if you cube a negative 1, positive and negative 1. And then same thing here. Square root of 16, technically positive negative 4. When you cube the positive 4, 64. You cube a negative 4, negative 64. So yeah, technically the positive negative, your calculator won't do that for you. It won't put the positive negative. So here's a good thought to maybe keep in mind. If the denominator is even, remember, the numerator is your power, the denominator is your root. That goes all the way back to the beginning of the school year, right? If the root is even, you've got to remember technically positive negative. So right here, when you actually do the work with it, that's positive negative 1. That's positive negative 4. Then you have to turn around and cube. Does that make sense? Questions on that? So I've got 4 possible answers so far. Now for the fun part. All right. Cube root of 1 to the 4th, 1. Cube root of 1 squared times 17 minus 16. All right, let's try the negative 1. Cube root of negative 1. Negative 1 to the 4th, positive 1. Cube root of negative 1 squared times 17. And sure enough, both answers check out. Let's do the same with the 64. The cube root, the denominator is the root, cube root of 64 to the 4th power. We did memorize 256, all right. Cube root of 64 squared. 16 times 17. 272 minus 16, does that equal 256?
Yep.
Now for the negative 64. Cube root of negative 64. Negative 4. Then you raise it to the 4th power, right back to the 256. Same thing's going to happen here, right? Cube root of negative 64 is negative 4, but then you square it. Positive 16 times 17 is going to be 272 minus 16. So again, both positive and negative check out in both cases. 4 roots. How many who were able to finish, you maybe didn't get the positive, negative, but at least got the 1 in 64? Did anyone think through the positive and negative? Does it make sense now? Okay, so if you've got an even denominator here when it comes to doing the math, if the denominator ends up even, that's an even root, so you've got to put that positive negative there. Let's take a look at this problem together here. And again, I told you, you want your exponents to have matching denominators. This is a 5 over 3. This is a 4 over 3. This is a 1. Thoughts? Class? What? 3/3. And if you'll make it a 3/3, now you should see a common factor. What's common to everything, Kendall? 3/3 of an x. An x to the 3/3 is common. Kendall, what would I get if I pulled 3/3 of an x out of everything?
2x, 2/3, 3x, 1/3, and then x.
Well, there was 3/3 of an x there, and I pulled all 3/3 of an x out.
1.
1, because we're dividing it out technically, so when you divide, you get a 1. And now, quadratic form, double, regular, gone. So I can keep the x to the 3/3, don't lose it, and we can factor here. Genesis, how would I split up a 2x to the 2/3?
1x and 3.
Well, first of all, how do I split up a 2, obviously?
3. Okay, 1
and
2.
2. And x to the 2/3 should split into x to the
1/3.
and x to the
1/3.
there we go. So 1x to the 1/3, 2x to the 1/3, there's your 2x to the 2/3. Signs?
Oh,
Both negative. And the only way to split up a 1,
1.
this would better work, or else
We're doomed.
we have to do the quadratic formula, which would be really sad. All right, I might show it eventually, but it takes forever. I don't like to do it. So hopefully this works. Does the outer inner check, class? Yes, so we're good. So now I've got 3 of these little things. I've got an x to the 3/3 equals 0. Then x to the 1/3 equals 1. And a x to the 1/3 here, class, is going to equal 1/2. Add the 1 over, divide by 2. Now here, x to the 3/3, class, that's just x. Like x to the 1st, that's just x. So x equals 0. Okay, we're good to go there. On both of these, I'm going to have to raise to what power, Michael?
The third power.
The third power. I'm going to cube everything because that's the reciprocal. Okay, so that's going to give me here, class, x is equal to 1, and here x is equal to
1 over 8.
1 over 8. There we go. However, you better check. Well, if x is 0, then this is 0. Minus 0 plus 0 equals 0?
Yes.
Well, this is an odd root, so there's no positive, negative, or anything weird to worry about here. So 2 times 1, 3 times 1, and 1 is 1. Okay, is that equals 0? All right, so literally the only one we have to work is that 1/8. You boy. All right, on your calculator. 1/8 to the 5/3 power.
Twenty.
1/32, right? 1/32, right? 2 times 2 becomes 1/16. Was it an earthquake for a moment there, Genesis? The whole room began to shake, at least to the people on YouTube. All right, then 1/8 to the 4/3. Times -3, of course, would be. And then plus, and again, it's x to the 3/3, that's just x, right? Plus x means plus 1/8. Does all of that equal 0? A 16th minus 3/16 plus an 1/8 equals 0.
Yeah.
Yes. Because if you think about it, this is 2/16. 1/16 minus 3/16 plus 2/16. Yes, it does. All 3 answers check out. And there we go. Questions on that one? Like, it's our first day back after Thanksgiving. I know, it's an unfortunate place to have to pick up in the curriculum. All right, next one. Take care of it yourselves. Similar to this one. just a little more friendly, I think. You'll find out. Back that up for a little bit. Few people already finished. So we should have written the x as an x to the 2/2. Did we do that? Then that means we're going to put it in the middle, so we have the descending 3/2, 2/2, 1/2, but there's at least half an x everywhere. So did we pull out the x to the 1/2? That leaves us x to the 2/2 minus 3x to the 1/2 minus 10, and then of course all equal to 0. Keep the x to the 1/2, don't lose it. Factor in x to the 1/2 minus 5, x to the 1/2 plus 2. And that gives us 3 little possible solutions for x to the 1/2, which is 0, 5, and negative 2. But, class, what do I need to do everywhere? Square everything, right? Because these are technically all square roots of x. So when we square everything, I end up with 3 possible answers for x, class.
0,
25.
0, 25, and 4. Now, one of those, my internal radar is going off saying, I bet it's extraneous. Which one? The 4. Why, Abby?
Because 4 to the 1/2 is 2 plus 2, that's 2 the same. You said you can't have multiples of something in a fraction?
because it's a square.
Well, they're all squares.
Oh, yeah.
That's how we got them with squaring, right? But what was unique about squaring to get the 4?
It was negative.
It had been a negative. And remember, I told you, maybe jot this in your notes again if you've forgotten. Again, it's been a little while. It's oftentimes when you square the negatives that you get your extraneous roots. And it's not always is the hard part, right? And it doesn't mean the 0 and 25 won't be. But oftentimes, that's where your extraneous roots will come. So I'm pretty confident in the 0. I'm not absolutely confident in the 25, but I'm not really super suspicious either. But that 4 It's like Brandon, almost like, I don't know about that 4. Anyway, watch it carefully. All right, so the 0, 0 minus 10 times 0 would be 0 minus 0 equals 3 times 0, which is 0. So class, yeah, checks. All right, let's try the 4. 4 to the 3 halves means the square root of 4 cubed. Square root of 4 times negative 10. And then this is 4 to the first, right? Square root of 4 squared is 2 squared 4, right? So 3 times 4 is 12. No, that'd be negative 12. So I was right. This one is extraneous. Again, that negative being squared. Let's see about the 5. Rather the 25. Square root of 25 cubed. This is why we memorize our squares and cubes. Not that your calculator can't do it. Square root of 25 times negative 10.
Negative 50.
And of course, this is just a 25, right? 3 times 25. Checks out. And there we go. Of my 3 possible solutions, 2 of them work. How many had 0, 25, and 4 as your possible roots? How many circled them all and were too lazy to check? How many checked and found the 4 was extraneous? How many didn't check properly and got all 3 to work? All right? Questions on this? Questions on this? I know some of you are still working. How far did we get? Give me some feedback if you didn't finish. Where were we at? Come on, want some feedback? You good?
I got square everything.
So you got this
square,
far.
Yeah.
Okay, but you knew to square? All right, good. Anyone else? Kendall, how we doing? I know you missed our last lesson. Had to watch it on video.
The answers, but I didn't have time to check.
Okay, all right. But you knew to check. Okay, good. All right. All right, well, next thing in your notes then. We've been working here, obviously, with polynomials that involve fractional exponents, but what if the entire polynomial was raised to a fractional exponent? That'll be our next section, equations with polynomials raised to rational exponents. Polynomials to rational exponents. I don't feel like these are too bad. For instance, write this down in your notes. If we have an x plus 2 to the 2/3, all equal to 16. Well, this isn't too different from a radical equation still, right? It's just the radical is more than just a number or just a letter in the radicand. There's just, right, we had square root of like x plus 5, right? Equals 7, let's just say. Well, you would square both sides, wouldn't you? Right? Well, here, I'm going to cube both sides, or rather, let's knock everything out at once. Raise both sides to the reciprocal power. That's your first key step. Raise both sides to the reciprocal power. You could say raise everything to the reciprocal power because this is grouped together collectively as one thing. But here that reciprocal power class is the 3 halves. Now again, notice that your denominator is even. This is an even power. Even powers, even denominators, you have to remember positive, negative. So here the 3 and 3 cancel, 2 and 2 cancel. I'm just left with x plus 2. But here the square roots of 16 are positive, negative 4, and both of those now have to be cubed to get 2 possible numbers here. Positive and negative 64. Questions on that? Again, your calculator will not do this because it can't do positive and negative. It can only do one answer. It's going to say positive. You have to think of both positive and negative. Though you can plug it into the calculator, as long as you remember positive, negative. Now it's an easy step, class. What would we do to solve for x? As a... So that gives me 2 possible solutions for x. 64 minus 2.
Negative 66.
Well, that would be negative 64 minus 2. How about 64 minus 2? 62. And of course, negative 66 would be my other possible solution. With these, you're not as likely to get the extraneous roots. Either of them will give you either 64 or negative 64. Cube root would either be positive or negative 4, but when you square them, they would come to the 16. So you're not as concerned about extraneous roots here, though not possible, I suppose. Questions on this? Do you see how it's intuitive? Right, it follows the steps we would expect to see. Write this down. Y negative 4 to the 3/4 power is equal to 8. Y minus 4 to the 3/4 power is equal to 8. What should I do here, Maddie? Excelente. And of course on the left side, Maddie, all we're left with is... On the right side, how is a good way to read 8 to the 4/3 power, volunteer? How should I process that in my brain? Start with the root. Class, this is the cube root of 8 raised to the 4th power. I would start with the cube root of 8, class. Positive and negative 2? Not on a cube root, remember. Odd roots, you don't have to worry about positive and negative. So just, cube root of 8 is just 2. To the 4th, 16. And now, easy step, class. 4 over as a positive to get y equals 20. Again, if you wanted to check, 20 minus 4 is 16. 16 to the 3/4 power means 4 through to 16, which is positive or negative 2. Cube, let's assume the positive 2 would be 8. The negative 2 wouldn't, but you plugged in one number, so it does check. It's one way of reading it, may not. And there we go with our 20. Questions on that? Write this one down. 2d plus 5 to the 4/3 equals 81. 2d to the 4/3 equals 81. What do I need to do here, Kendall?
Raise both sides to the reciprocal.
Which is
3/4.
3/4. Kendall, how should I think through the 81 to the 3/4? Obviously on the left side, it's just canceling 2d plus 5. How should I think through 81 to the 3/4?
4 through 81.
And then,
To the 3rd.
or cube it, right. So since it's an even root, class, I need to think both positive and negative. Technically, by the way, there's 4 roots, a positive, a negative, an imaginary, and a negative imaginary. Don't worry about the imaginaries, focus on the reals. 4th root of 81. 3, but we're going to think positive and negative 3. Then we're going to cube both positive and negative 3. Positive and negative 27. Again, that's the 4th root of 81 cubed, which is positive negative 3 cubed. That's where we got the positive negative 27. Now what? Genesis? Well, I could say 2d plus 5 equals 27, 2d plus 5 equals negative 27. Not a bad strategy, make it a little easier for us. In each case now,
Subtract the 5.
and that's going to give us a couple different things. 2d here would equal, but here 2d is going to equal
31.
negative 32. 7 and 5 is 12, so negative 32. And then in each case now we have to divide away the
2.
So that's going to give me 2 answers for D. D is either equal to or divided by 2, which is you have a calculator, you can use it, no problem, especially on Monday. But negative 16, right? Because of that there. All right, so if we plug in the 11, of course, 2 times 11 class, plus the 5, 27, cube root of 27, to the 4th is 81. Of course, the negative 16 times 2 is negative 32, plus 5 is negative 27. Cube root of negative 27, negative 3. But again, you raise it to the 4th, you're right back to the positive 81. Both roots will check. Questions on this? Let me have you do just a few of these then. Page 134. Do numbers 24, 29, and 30. 24, 29, and 30. pretty, but there you go. If you're on 29. Double check it myself. You can double check your answers on these three. 29 is awful, but there you go. And then the seventh root. But again, you've got a calculator. You know there's not going to be a positive negative because it's odds. You just do 128 to the 5/7 does come out to 32, because 2 to the 5th is 32. There we go. How many got all of them correct, or the ones you did right? If you didn't finish all of them. Any questions on this? You'll do some of these for homework as well. Any questions? All right, your homework for this evening. Homework for this evening is to do page 134. By the way, real quick, while you're still on page 134, most of you, you'll notice, for instance, we didn't do number 31 we were going to. Notice 31, it looks more ghastly. It's like, oh, there's a trinomial. But you realize the 2g and the g just combine to get 3g, right? So if you look, for instance, at number 38, there's a whole bunch of terms. Well, if you combine like terms first, it really is basically exactly like the other ones. There's just that little extra step. Okay, you're going to have a couple of those in your homework as well. Page 134, numbers 21 to 37, the teal. Page 134, numbers 21 through 37, the teal. And on page 136, just two problems, 23 and 27. Page 136, 23 and 27. Again, page 134, 21 to 37, the teal. Page 136, number 23 and 27. Have a wonderful rest of your day, and you are dismissed.